Hello everyone, welcome back to your YouTube channel Physics with Oliver. If you are new in this channel, please subscribe the channel and keep watching. We will start today's problem. Okay, let's start. Find current through 100 ohm resistance in the circuit shown in the figure containing two diodes D1 and D2 each with a forward resistance of 50 ohm and with infinite backward resistance. Okay. At first, we should understand what is forward bias, what is reverse bias, and what does it mean by forward resistance and backward resistance. Okay. So, if this is a diode, we know this. This is the P end, this is the N end. Okay. This is positive end, this is negative end. So, if we connect the diode with a battery in this manner, if we connect the positive end of the diode to the positive end of the battery and the negative end of the diode to the negative end of the battery, then it is known as forward biasing. Okay. If we connect it oppositely, if we connect the positive end of the diode with the negative end of the battery and the positive end of the battery with the negative end of the diode, then it is known as reverse bias condition. Okay, this is forward bias condition. Okay, now we can see from this figure, I am showing you this from the figure, I am not drawing it again. The positive end of the battery is this, right? This positive end is connected with the positive end of D1 diode and the positive end of the battery is connected with the negative end of the D1 diode, right? And this is the negative end of D1, this is the positive end of D2. Okay, from the figure we can easily show that the positive end of D1 diode is connected to the positive end of the battery and the negative end of the D2 diode is connected to the positive end of the battery. So from here we can say in this situation D1 is in forward bias condition and D2 is in reverse bias condition, right? So in this situation, it is written in the question that two diodes D1 and D2 each with a forward resistance 50 ohm and infinite backward resistance. That means when the diodes are connected in forward bias condition, then the resistance it offered in the circuit is 50 ohm. But when the diode is connected in reverse bias condition, then the resistance of the diode is infinite. Okay, that means we can replace the circuit like this. We can replace the diode by its resistance. D1 is connected in forward bias condition, so the resistance will be 50 ohm. So we will draw this 50 ohm resistance here and we will draw this 50 ohm also. Okay, the first 50 ohm is due to the diode D1 and the second 50 ohm is from the circuit, and D2 is connected in reverse bias condition. And in what is the reverse resistance? Infinite backward resistance. Forward resistance means resistance in forward bias condition, and reverse resistance is similar to the backward resistance, right? So D2, the resistance of D2 is infinite. So here infinite resistance means actually the circuit is not connected, right? Infinite resistance, and we will draw this 150 ohm here. This is 150 ohm and this is the battery of 6 volt and this is 100 ohm. Now we have to calculate the current through 100 ohm resistance in the circuit. We have to calculate the current through this resistance, right? So from the positive end of the battery the current will flow. See, the current is flowing. Why the current is not entering in this path? Because the path is disconnected. Infinite resistance means the path is disconnected. If the current always follow the path of smaller resistance. It always try to go through the path where less obstructions is there, right? So it will choose the easy path. It will not follow this path where the resistance is infinite. Resistance means obstruction. Okay, so it will follow this path. It will not follow this path. So current is flowing in this way. Again the current will not flow in this way because infinite resistance is there. Circuit is disconnected. The current is following this circuit. So actually this path is not followed by the current. So now the circuit actually become like this: 50 ohm, and then the second 50 ohm, first 50 ohm due to D1, and the second 50 ohm is from the circuit, and this is 6 volt, and this is 100 ohm. So the total resistance of the circuit is 100 plus 50 plus 50, that means 200, and the voltage is V. We know V equals to IR from Ohm's law. So we can write I is equals to V by R. V is equals to 6 and the resistance is 200, right? So we can calculate this. Let's see, we will cutting this with 3, so this will be 3, this will be 100. So from here we can write, I'm not getting space here, so I'm writing this way. Okay, this is the current which is flowing through the circuit. It is asked what amount of current is flowing through this 100 ohm resistance. So the current flowing through the 100 ohm resistance is 0.03 ampere. So this will be the correct option. Thank you everyone for watching the video. Please subscribe and like the video. We will come with another problem in the next video.